So I've mentioned PTX a few modules back, saying that it's basically kind of like the assembly language of CUDA, similar to intermediate language in .NET or the Java bytecode. And even if you don't get to see it, unless you want to, of course, you can still get PTX output by either using the PTX flag if you're calling in VCC directly, or just specifying an appropriate project setting. So there is enough there to satisfy your curiosity. And one thing about PTX that's relatively useful, and we're going to look at it later, is the ability to load a PTX kernel at runtime. So essentially you can use the driver API, which we're going to talk about, to load a chunk of PTX code effectively while your program is running. So load a whole kernel and execute it and get the results, which can be useful in certain situations. One thing I wanted to mention here, though, is the ability to embed PTX right into your CUDA kernel. So this is kind of like the ability to embed inline assembly in C++ code that some of you might have seen. And the idea here is similar. So you have this ASM instruction, which essentially lets you splice the PTX right inside your kernel, and you can reference variables and invoke the instructions from the PTX language. So if you're into this kind of low-level stuff, if you're into kind of heavy optimization, then this is another possibility that's available to you.